Today's video is going to talk about the third and final method for solving for a system of linear equations. So far we've done solve by graphing and now solve by substitution, and now we're going to do solve for using the elimination method. So again, we're going to have a couple steps that we're going to need to go through. The first step is we're going to arrange the equations with like terms and columns. So we're going to want all of our like terms to line up in columns before we start to solve. Again, we're going to do examples, so this will all make sense in just a few minutes. After we do that, our second step is we're going to multiply one or both equations by a number to obtain coefficients that are opposites. For one of the variables. Okay, so first, after we arrange them in columns, then we're going to multiply one or both of those equations by a number to obtain a coefficient that are opposites, and that opposite is going to make them cancel out, and that's where the elimination comes from. Third, we're going to add the equations from step 2. Combining like terms combining those like terms will eliminate one variable. And then we're going to solve for the remaining variable. So one variable, right, we're dealing with two. We're dealing with most of the time x and y, but it could be other variables. So one of those variables is going to be eliminated, and then we're going to solve for the variable that's left over. After that, we're going to go back and we're going to substitute the value from step 3 into either one of the original equations. So you can pick either one, whichever one makes it look like it's going to be easier to solve for. And like I said, you're going to solve for the other variable. All right, and one final and last step, which seems to be consistent with all of these, that fifth and final step is of course optional, but definitely I suggest that you do take advantage of that. Not always in algebra or in any math are you going to have the chance to check. So when you do, you might as well give it a try. You're going to check the solution. And you check the solution the same way, right? The solutions to these are going to be ordered pairs. So you would check it by plugging the ordered pair back in just like we did before. Okay, so I know that the steps were a little extensive, but let's take a look at some examples and it'll make a little bit more sense for you. So my first example I'm going to do 4x plus 3y equals 16, and 2x minus 3y equals 8. So what this does, or, sorry, let me rewrite these. So the first step says that you need to arrange these into columns with like terms. Well, that is already done for us here. If you notice, this column has our x's, this column has our y's, and this last column over here has our constants. So you're going to want to set it up so yours look like that every time. For this first example, the second said multiply one or both equations by a number to obtain coefficients that are opposites for one of the variables. So what we're trying to do here is essentially what already happened for us in this equation. If you look at this equation, I have in this middle column, I have a positive 3y and a negative 3y. That's exactly what I'm looking for, because now I could cancel those out. And then what I'm doing is I'm going to add the equations from step 2, and I'm going to combine my like terms down, okay? So let's look. I have right here in this column again, I have 4x and 2x. 4 plus 2 is 6x. My middle column canceled out, and then I have left over here, I have a 16 and an 8. I'm going to combine those. 16 plus 8 is 24, and now I can solve for x. X equals 4. Now that I have one of the solutions, I can plug it back into, and it says either equation. I'm going to pick the first one. So I'm going to plug it back into 4x plus 3y equals 16. Well, 4x plus 3y equals 16, and I already found x to be 4, so I'm just going to plug it right back in. 4 times 4 plus 3y equals 16. 16 plus 3y equals 16. I'm going to move my 16 over, and I'm left with 3y equals 0, so my y value is 0. So my solution is I have 4 over here and 0 here. So my solution is 4, 0. Again, I could go back and plug that in and check that it worked out. Every time you should do that. All right, so let's look at another example. I'm going to write it over here. So my next example is m plus 2n equals 2 and negative m plus 2n equals 3. Again, when you're listing these, you should list them in alphabetical order. So LM comes before N, so we're going to list that one first. And now if you see again, I don't have to, I'm already in step 1 because I'm already arranged in columns. I have my M's, I have my N's, and I have my constants. So now I don't need to multiply these by anything, because if you see, I already have in my M column, I have a negative M and a positive 1M. So these actually eliminate each other. Okay, that's what I'm looking to get, but they already had it's already done for me here. So now I'm just going to continue with the next step. I'm going to combine my equations by like terms. So I have 2n plus 2n equals 4n. Oh, I wrote this wrong. Hold on. This right here, sorry, I'm wondering why it didn't work. Should be a 3n. So just fix that quickly. Okay, so now when I combine these terms down, I have 3n plus 2n. I get 5n equals 5. So now I can just solve for n. N is equal to 1. Okay, so if you remember, excuse me, now we have to go back and plug this in. And it doesn't matter what equation you use. We already know that n is 1. So I'm going to go back and I'm going to plug it in the first equation. The first equation was m plus 3n equals 2. So I'm going to go right ahead and plug it in. M plus 3 times 1 equals 2. M plus 3 equals 2. Subtract 3 from both sides. M is equal to a negative 1. So my solution So my solution is going to be the point, and remember, we talked about this last time, when you have variables that are not x and y, you need to list them from left to right in the alphabet. Because m comes before n, I'm going to do -1, 1 as my solution to that system. And again, you could check the solution. All right, let's look at another example that's a little bit more complicated. So my example here is I have 3x plus 5y equals 6, and -4x plus 2y equals 5. Now I have to somewhere manipulate these equations, one or both of them, so that I can get some elimination to happen. So I'm going to look at this and be like, okay, well in this first column in my x's, I already have one that's positive and one that's negative. So that's a good start. They're going to cancel each other out. I just have to make them become the same number. So the way I'm going to do that is I'm going to multiply this top one by 4. So I'm going to get 12x plus 20y equals 24. Well, then just like I did to the top, I'm going to do to the bottom, but this time I'm going to multiply the bottom by 3 because I want those leading numbers to both be 12 so that they could cancel each other out. Now, as long as you're doing it to the whole equation, it doesn't matter. It doesn't matter that we're multiplying by 4 or 3. As long as you multiply every term in that equation, it's okay. So now I multiply everything by 3. I get -12x plus 6y equals 15. And now I am in the position where I can eliminate my x's. So I'm going to come over here. I'm going to eliminate my x values. I have 20 plus 26 is 26y. And then 15 plus 24 is going to give me 39. And then I'm going to go ahead and divide by 26. And after simplifying, I get y is equal to 3/2. So now I have one of my values. Now I have to go back and plug it into equation and see what my other one is. So looking at these equations, I'll write them off to the side. And we talk a lot during this unit about picking the one that looks like it's going to be the easiest for us to compute. So I know that my y is 3/2. It looks like I would want to multiply it by this too, so it'll cancel out. So this is the equation I'm going to use. -4x plus 2 times 3/2 is equal to 5. -4x. These 2's cancel each other out, so I'm just left with 3 equals 5. I'm going to subtract 3 from both sides. I get -4x is equal to 2, and divide by that -4, and I get x is equal to -1/2. So my solution is -1/2 and 3/2 is my y, sorry. All right, so that was a little bit different, and we added another step where you actually had to multiply those equations so they could work with you so you could eliminate them. So let's look at another one. So I'm going to do 2g minus 3h equals 0, and 3g minus 2h equals 5. So think for a minute, what can you do to multiply these to get them so you can get something to eliminate? Well, I have a 3 and a 2 in the front, so I'm going to try to make those into a 6. And I need one to be positive and one to be negative. So I'm going to start with my first one. I'm going to multiply this top by -3. When I do that, I get -6g plus 9h equals 0, right? I went to every term in that equation. Well, I need to get a 6 on the bottom, so if I look at this bottom equation, I need to multiply this by 2. And that's going to get me that 6 up front that I need. So 2 times 3g is 6g. 2 times a -2h is a -4h. And that is equal to 2 times 5, which is 10. So now I have my equation where I need it. I have this negative positive g situation. They're going to eliminate each other. So now I have 9h minus 4h is 5h, and 0, the difference of 0 and 10 is 10. We're not that hint right here. This 10 is not, remember, you're combining like terms. You're not subtracting. So this is not 0 minus 10. This is you have a 0 and you have a positive 10. So make sure that we're noticing that, because I almost made that mistake for a second, right? We're not subtracting 10 from 0. We're combining like terms. You have a positive 10. This is technically positive, and that 0. So 0 plus 10 is 10. Divide both by 5. H is equal to 2. Now that we found our h, we can go back and plug it into another equation. I'm going to use the 1 on the top, so I'm going to say 2g minus 3 times 2 equals 0. I have 2g minus 6 equals 0. Add the 6 to the other side. 2g equals 6. Divide by 2 on both sides. G equals 3. So my solution, remember, we have to arrange them in order. Since G comes before H, I'm putting my G first and my H second. All right, let's do one more example where we kind of have to do a little bit of everything. So let's look. So I have 3x plus 2y equals 8, and I have 2y equals 12 minus 5x. Well, if you notice, these equations are not lined up in columns. That's step 1. I know we kind of got off from naming the steps, but if you look back, step 1 is to make sure they're arranged in columns. These are not, so I have to move this 5x to the other side. So I'm going to rewrite them just because it's easier for me to see that way. So I have 3x plus 2y equals 8, and now I can put my 5x in the front. I have 2y, and I have 12. Well, if you notice, in my y column, I already have a 2 and a 2, except one's positive and one's negative. So I need to change one of those to a negative. So all I'm going to do is I'm going to multiply this top equation by a negative 1. So I'm just going to rewrite it right here under this other equation. Negative 3x minus 2y minus 8. So now if I eliminate my 2's, I have 2x equals 4. Divide both sides by 2, x equals 2. So now I can go ahead and pick one of those equations. I'm going to pick the top one. I have 3x plus 2y equals 8. So I'm going to substitute in my 2. And then divide by 2, and I get y is equal to 1. So my solution to this system is going to be 2, 1. All right, well, that's enough examples for now. We will definitely work more when I see you in class.